Good morning. Thank you for dialing in to this week's session, IPC Technologies, our customer training webinar series. What we're going to talk about today is we're going to talk about SIP. What is SIP? So migrating to SIP, or if you've already migrated or considering a migration, we have a lot of experience in helping customers make decisions on architectures, how to deploy. Some of the things we want to do is, some of the lessons learned along the way. It's always good when you're not the first one to do something. So everyone on the call today, if you're considering a SIP migration, you can rest assured that we have done this many, many times for our other customers and have sort of learned the good, bad, and the ugly, and the things to watch out for and where to sidestep and those types of things. So, SIP is it plays a very important role in the communications platform for both the Mitel platform on My Voice Connect and My Voice Business. It's been around for a long time. It's within our carrier spaces internally. And so what we want to do is maybe debunk some myths and then show you several different ways to migrate. We're going to begin with maybe a little lesson on what is SIP, what are some of the ramifications of moving to SIP, some of the regulatory guidelines around 911, and some other considerations that you'll want to bake into your migration strategy. And so for today's session, we have our resident expert, Jonathan, online to facilitate and lead this discussion on SIP. So Jonathan, I'll go ahead and turn it over to you.
Thank you. Appreciate that, Eric. Okay, so just to address the elephant in the room, yes, I'm born and raised in the South, in Charleston, South Carolina, so I do have a Southern drawl, so you'll have a Southern version of the presentation today. One of the questions people ask all the time, they hear this term SIP, what is it? What are we talking about? Why is it so important in the industry? And why are the telephone carriers really pushing and looking at this particular type of protocol? Okay, what it is, it's just a very basic application layer protocol, and it works by two different endpoints talking back and forth to each other. One of the reasons that the carriers really like this product is in bullet 2, you'll notice it's really controlled and dictated by the IETF. It's not totally regulated by the FCC. Whereas more of the PRI and traditional analog lines and things of that nature are more stringently regulated. So it gives the carriers a little bit more flexibility, a little bit more freedom to do things. SIP is not a standard. That's a misconception a lot of people have. We get requests all the time, people saying, hey, we just got to make sure it adheres to SIP standards. Well, that's kind of a general statement because it's not really a standard. It's a request for comment. It's called an RFC. And as such, what we find is different carriers have their own different methodologies, their own equipment that they use for providing SIP to the different customers. So where AT&T might be using IP Flex, Windstream is using something else, Verizon's using something different. And each one is sending something in a different manner. And we're going to touch on how we
Jonathan,
those different methodologies. Yeah.
Jonathan, just real quick, I've heard it referred to, if you picture a large oak tree with all its leaves off, right? You got this huge oak tree that that branches everywhere. You just close your eyes and picture that tree. You can be in the tree, but on a completely different branch in a completely different area in that tree. So you can still be within the SIP RFC, but have made deployment and development decisions on how to implement SIP. So you can still be within sort of the framework of the RFC, but on a completely different branch. And that was just, I like that visual. Someone shared that with me years ago to sort of explain what you're talking about. It's not a standard. It's not like, hey, this is the only way to do it. So you can be within that SIP standard, but have made lots of different decisions about how you wanted to deliver the protocol in multiple branches in multiple ways. And you make one decision, it leads to another branch. You make another decision, it leads to another branch. And all of a sudden you find yourselves in the same tree, but one's on the north side and one's on the south side. So I like that image as just an example of how to explain what you're talking about, it not being a certified standard within the industry.
Yep. Thank you, Eric. And last thing here, if you think of it, it is an IP-based protocol. It is running over the internet, and it's running inside your network on IP. And so basically, if you think of it, it's similar to almost what you're doing with PCs and a server, PCs to PCs. You have one endpoint, which is a phone, and the other endpoint is someone else's phone, and you're initiating a call back and forth, and it's running using IP. It says, hey, I'm sending you a message, and the receiving phone says, hey, I received that message, and sends a message back saying, hey, I received it, and let's talk. So if you think of it, it's almost like a network, peer-to-peer network in that manner. Once it's established its connection, it's just going back and forth between the different endpoints. Okay. Some of the reasons and why people are wanting to move to SIP, big one, the 800-pound one that everybody needs to be aware of, is AT&T announced their intention that they're going to start phasing out traditional PRI circuits in 2020. They have actually gotten state legislatures so far in 20 states, and there are more coming to approve this. And the reason, there are lots of different reasons why they're doing that, but the main reason is the technology for traditional PRI is older. You have the smart jack on the wall, and it's harder and harder for them to support and maintain it. A lot of the benefits that the people are seeing on this is the SIP circuits are being built at lower rates because the carriers are wanting people to move to this. They're pushing it. And it basically is eliminating long distance. If you do go to a true SIP circuit, it pretty well eliminates all long distance in the continental U.S. And it also lowers when you're going to other countries. When you look at 911, that's really where a lot of the benefit of SIP also comes into play, as well as the ability to do additional redundancy and different methodologies of building redundancy, which we are actually going to touch on later on in this presentation. The 911 is really one that's starting to rear its head a lot. And that's where this comes into play. The FCC, a lot of people aren't aware of these, but there are some new regulations that were passed between 2017 and 2018 that are going to be kicking in and going into effect starting 2020. There's one that's called Kerry's Law. Okay, where the two impacts of this are that carriers and people like IPC, when we're putting in phone systems, we're going to have to be able to address the fact that somebody can pick up a phone and dial 911 and the call goes out to 911 dispatch. The little bit of a history lesson behind this, where this comes into play, is there was a young lady and her mom, little girl about 9, 10 years old, staying in a hotel, and the mom had an emergency. And the little girl, doing what she was trained to do, picked up and dialed 911. Well, the problem is on the older phone system that was in that hotel, you had to dial 9 to get an outside line. So the mama wound up having to go in critical condition to the hospital because the little girl kept dialing 911 and couldn't get anybody to pick up. The second part of that particular act is that it's going to require that on-site personnel be notified that a 911 call has been placed from your establishment. And they're going to want it to get to where it lets you know what extension or what location internally has placed that 911 call. And there are different ways of doing it. In our world, for instance, with the My Voice Connect, we can use what's called emergency notification. It'll do that automatically. That's its whole purpose. It'll do pop-ups on the screen, and it'll call the people that need to be notified saying, hey, you've got a 911 call in place from extension such and such at this location. So we can address that, and most of the major players, the Avayas, the Ciscos, the Mitels of the world, they've already had the 911 goes outbound regardless of what you, if you hit 911 or just 911, the call still goes out. Most of them have addressed that years ago, so that's not really that big an issue. Some of the smaller carriers, some of the smaller IP telephony phone systems are where you actually see this become more of an issue. Ray-bomb is more so where you have to be able to send the information to 911 dispatch as to where the call is originating from. Where is this call coming from? And the reason this comes into play is there was an incident where a gentleman was at a school campus and he needed help, dialed 911. Well, if you have a PRI, it only terminates and it only sends out the address of where that PRI is terminated. So if I have 8 buildings, multi-story buildings on a campus, and the only thing that's going out is the address of the campus, that's not really going to do anybody any good as far as helping that guy get there. So between Kerry's law, where it will say to somebody internally, hey, there's a 911 call in place from this extension at this location, that information also will be passed out according to Ray-bomb Act. SIP greatly enhances the ability to adhere to these 2 new regulations that are going into play. Cannot emphasize enough how E911 has been addressed using SIP to address these. This is the big push behind it. The carriers aren't really saying that, but this is what's really pushing this. Earlier, I mentioned that it is less expensive, and SIP that saves money, and we can build redundancy, things of that nature. This is a real-life example of where IPC was asked to look at a real estate company and say, they ask, what can we do to improve our phone system's performance and reduce costs? Okay, well, the guy had a full PRI at every location with backup POTS line. He had 9 locations. So you're thinking, okay, so you got 9 full PRIs. That's 23 trunks at every site. I mean, some of these places had 10 people. They got 23 trunks. So I went in and did a download. I looked at the trunk utilization. And over a 3-month period, you're only using maybe half, if that much. And kind of a rule of thumb I use is if I do a trunk utilization report and a trunk has only had 9 or less inbound or outbound uses in a 3-month period, I don't really consider it in the SIP design. But this guy was, between the PRIs, the circuits, the long distance, things of that nature, this guy was paying over $7,000 a month, which, yeah, that's a bit stiff. So based on what I saw for usage, and he did want to have redundancy, so in case one location went down on the SIP, he'd be able to fail over and have redundancy. We set this up with 50 primary and 50 failover. The way we work with some of the different carriers, one of the main carriers that IPC likes to work with is a company called IntelliPeer. They used to wholesale SIP trunking to other carriers, so they have a very good understanding. We work with them a lot just because how good they are technically. But what they like to do is they can provide you with 50 X number of primary trunks. In this case, we use 50 primary trunks. And then we have 50 failover SIP trunks. Those are just basically sitting there in standby mode. What that allows us to do is, in the event the primary internet connection of the SIP trunks go down, all the phone calls, inbound, outbound, switch over to the failover SIP trunks. In that same train of thought, there's a term in the industry called bursting. Okay, so what happens is if they have 50 calls simultaneously going on and 2 more calls happen, the system has enough intelligence to go out and just grab 2 trunks off the failover SIP trunk group and utilize it. It's kind of a no harm, no foul. I mean, it's just rare occurrences that happened, and you move on. And that's been very attractive to a lot of customers in reducing the total trunk count utilization that they have in place by having the failover SIP trunks available. We can do it as an active where it's balancing between the two sets of trunks, but the primary with failover has been a pretty popular design that we've been doing. By eliminating the long distance and eliminating all these PRIs and the equipment associated with it, we cut the cost down to $2,000, a little bit less than $2,000 a month. And this resulted in a savings of approximately $5,000 or $60,000 a year, $5,000 a month or $60,000 a year. Okay, and while this is, an extreme case of savings, I mean, the gentleman who owned the company, he recognized that, he was spending a lot and he needed to address this. Generally, when we do these PRI analysis, if it's a multi-site location organization, we usually wind up saving people hundreds to thousands of dollars per month by just converting them over to SIP, and that's including setting it up with redundancy. So it's been a very popular move that IPC has been kind of leading the front on with our customer base. It's really very advantageous financially, and we actually have been getting additional new customers because they come to us saying, we want to look at moving to SIP, and we're just not comfortable with what we're being told by the carrier, what we're being told by our current partner. So we've been gaining customer base by doing that. But this is one example, and we've got dozens of these where we're saving people hundreds to thousands of dollars per month by moving them to SIP with redundancy. One of the things that I hear all the time, the account managers have calls and they ask me to sit in on the calls and we talk with customers. Okay, they say SIP is complicated. I mean, realistically, when you're looking at a SIP, like we do a capture and we're looking at a SIP package, it's text-based. So, if you know what the different terms mean, you can follow the entire flow of a SIP call. You capture a call, you can look at it and read it, understand it. Here's an acknowledgement. I'm presenting a call to you. The receiving caller says, okay, I see that. I acknowledge that I've received it. Let's continue to converse. It says bye when it hangs up. So, it's pretty straightforward. Usually, most people, if they're familiar with telephony or have worked around PBX systems or phone systems in general, they generally can pick up and understand the messaging back and forth with this, usually within about 2 to 4 weeks, if they just see it on a daily basis from time to time during the workday. The second one is the one that I really love. You hear people saying SIP is not as reliable, doesn't sound as good as traditional PRI circuits. I will suspect that most of the people on this call who do have PRIs have been approached by their carrier who provides PRI, and they've said, we'd like to upgrade our equipment sometime in the last probably 18 to 24 months. And what the carriers have been doing is they're converting you to SIP, handing off to a device called an IAD. It's usually like a router of some type, or a ADTRAN makes a device called an 810, but it's a device that's in the industry referred to as an IAD. And then that hands off to you as you're used to being given signaling and trunking as a traditional PRI. Well, what happens and what the carriers aren't telling you is while you, the customer, are still being charged for when your long distance goes out, you get an X bundle of hours or minutes based on your PRI. And then you also have charges for if you're going cross ladder, across different territories of different carriers. Some carriers have exclusivity in certain regions. And so if you cross their turf, quote unquote, there's a little bit of an additional fee for that. And that's passed on to the customers. Well, the carriers, once it converts to SIP, it's going over the internet. They're not paying any of those fees. You're still paying for it as the customer, but they are not paying those fees and costs anymore. So it's been a very profitable little model that the carriers have been using over the past 2 to 3 years. And it's all based on, oh, by the way, can we upgrade our equipment to something newer to provide you with your PRI trunking? And that's what they're doing. So it's kind of an interesting little thing that's going on in the background. One of the things I always like to just kind of give people a brief overview is what are the parts used in doing a SIP design. Okay, you're going to have an internet connection, and it can be a dedicated trunk, dedicated internet pipe that's just for SIP, or you can use your existing bandwidth if you have enough. What we find is when I'm talking with different customers, I'll say, okay, well, how much bandwidth do you currently have for your internet? And they'll say, got a 200 meg, 100 meg, whatever. And then the next thing I'll say is, can you get your internet service provider to give you a utilization report? And what we find is they can run a utilization report, and these people might be using, say they have 100 megabit bandwidth, and they might only be using 50%, 40% at any given time. Well, if that's the case, well, then yeah, we'll just put the SIP on top of what they currently have. And that's what you see right here on the second line is that you're running on top of an internet connection. And again, it can be dedicated or existing. Big point here, use a certified SIP provider based on your manufacturer. Don't go off the ranch. Don't let your purchasing department go out and go price shopping for SIP training and come up, because they're little mom and pop shops and places that are popping up everywhere providing SIP trunking. And oftentimes they are not approved. They are not, again, remember, it's request for comment. It's not a standard. And you do not want to go that path, because it's hard to get that to work with the traditional manufacturers' equipment and session border controls, things of that nature. The whole function that we have here, we have a session border controller. That's a very important piece, and we're going to get more into the depth on that particular item. The session border controller basically allows you to traverse your firewall. It provides security, and it does the translation between the signaling and media flows, as we call them, sessions, as I've got in parentheses here. These can be physical or virtual devices. In IPC's world, a lot of times we're using the in-gate separator, or we're using the MyBorder gateway, and both of those are supported in the VMware or Hyper-V environment, as well as you can get physical devices. But very important that you want to have a session border controller, because again, remember, your voice is coming in over the internet. It is going through your firewall. It is internet traffic. The session border controller will provide protection on that, and I'll get more in depth on that shortly. And then the last thing is the session border controller is just going to hand it off to some type of device that handles SIP trunking. In the MyVoice Connect under Mitel, we use a SIP trunk switch. MyBorder Gateway for the MyVoice business handles that. But every manufacturer, they have something that will take the signaling from the session border controller and take that handoff and convert it to SIP that is used by the manufacturer's product set, and then that allows you to have your dial tone in and out of the system. I'm hoping that's kind of basic breakdown, but it's pretty straightforward. And then we get into this. You have, do I really need a session border controller? I get asked this question probably more than any other question when I'm talking about SIP with people. Okay, again, if you think about what's going on, okay, I have somebody outside, I have somebody inside my firewall. We're calling each other, okay, so there's a session that's being initiated between those two endpoint devices, the outside caller and the inside caller. Okay, that particular flow or media stream, if it's a video, it comes through the border, which is the next line item. Okay, that's where you have separation between one network and another. For example, and I use the example here of the firewall does the demarcation between the outside world and the inside world. Well, if you get into a multi-site environment, you could have multiple firewalls. So you have different borders that have to be addressed. And the session border controller, one of its main functions is what's called doing firewall transversal. And it does also, for the technical people, it also does what's called NAT translation. So those are two big functions that are being done by the session border controller. But it also, and we'll touch on this further, it also is providing security and encryption on that signaling that's coming through your border. And then the last part of the name, the controller, is what we're talking about, where it is handling the transversing of borders and then handling the handoff to the different equipment that's on the other side, that's on the PBX side of the house. So it allows you to have, you can measure, you can see call qualities, you can see packets. You see a lot of information through the session border controller. It's a very powerful device, but it really is just, I use the term a lot. It's kind of like my translator for the whole thing. It makes the world a lot easier to deal with. And people ask, well, since we have to have it, is this considered best practice? Yes, it is. And the reason that you want to have the session border controllers in here, and I put this slide in just basically just to why is it best practice, and this is common across all the major manufacturers out there. I mean, my background, I've done Cisco IP telephony, I've done ShoreTel IP telephony, I've done MyTel IP telephony. So, I mean, you see this on all the major platforms. Okay, first, yes, it does network security. Okay, if someone is trying to hack into your voice transmission, the session border controller will stop that stream where they're trying to hack in and then rebuild it on the other side of the border with the correct information. So the hacker gets blocked off, eliminated from the stream, and then the call continues through. And the whole goal of this is this keeps the network private, so somebody's not able to get into. That's also true on your outgoing voice. Okay, we've addressed incoming where the hacker's trying to get to. Well, sometimes they try to intercept the outgoing. Well, what this does is this puts encryption on top of the outgoing voice packet. So whereas phone systems traditionally they'll want to use, as I detail here, TLS or secure real-time transport, RTP, secure RTP, the session border controller will also do a hardware level encryption. And what that does is that takes the load off of the PBX system from having to do that encryption as much. You can kind of control what is doing the encryption on the outbound more so by using the session border controller. And then the last real big reason, as we've touched on already, is the session border controller really provides the ability to interoperate between different manufacturers. For instance, your carrier may be using SIP, they may be using an AdTran system up in the cloud for their SIP providing, they may be using a Cisco system, they may be using a BroadSoft, whatever. They have some big piece of equipment or big pieces of equipment that they're using for providing SIP. You, in turn, have something else, totally different manufacturer that you're using internally. Okay, well, what the session border controller does is it does that translation that allows the codecs and the equipment from different manufacturers and different, G711 versus G729 codecs. I'm not going to get to the weeds on that, but just difference in codecs. It allows you the ability to communicate between the different manufacturers' products and different codecs. It does that translation for you. That saves you a lot of cost in the long run, particularly if you just spin up a virtual session border controller. I mean, most people have either VMware, Hyper-V somewhere in place. So what this allows you to do is you can spin up session border controller. You can have an image of it so that in the event something happens, you can just go back to the previous image and it's back up and running. Very popular design.
Hey, Jonathan, one other practice I've seen here at IPC is where we can actually use SBCs to also facilitate multiple dial plans across multiple manufacturers. And so what the session border controller does, it's not only the interpreter, if you will, between the various manufacturers, but it also gives you some digit manipulation capabilities to add digits and strip digits. So, let's say you're trying to interoperate with a U.S. domestic office and a European office, but it's a 4-digit to a 6-digit dial plan. We have found sometimes that session border controller is helpful in manipulating digits because it gives you a little bit more granularity, as well as interpreting between the two SIP protocols, but also some advanced capabilities with digit manipulation. So just another example of where that session border controller has helped us and our customers sort of facilitate interoperability between multiple manufacturers, even between multiple dial plans and digit links and those types of things. Just another thing to consider.
Yep. Thank you, Eric. And I know this slide, these are wordy, and I know that. But if people understand what the parts are of the SIP call, what the session border controller is actually doing, it generally makes more sense. That was the reason I put a little bit extra verbiage there, just so people would have that available if you were giving this to somebody else to look at later. I put a little bit more detail so they would have that to read to be able to understand it. Nothing else from these slides in this presentation today. Please remember this one. I mean, seriously. We hear the carriers, and a lot of times it's smaller carriers. They're trying to present a case so that they can win out against the Verizons, the AT&Ts, the Windstreams, the Intellipeers, the big players. And they say, we support SIP natively, so you don't need a session border controller. I hear that and just cringe. Okay, if that statement is true, why do every major PBX manufacturer either have their own or use a certified session border controller? If you look at that list, that's basically what's considered the big four: Avaya, Cisco, Mitel, and Microsoft. Microsoft's kind of getting there. They're not there yet, but they're getting there. Every one of them. I mean, Avaya manufactures their own border controller. Cisco bought the Cube and have incorporated that into their IP telephony system. What used to be ShoreTel is now Mitel MyVoice Connect, uses the Engate separator. That's their preferred session border controller. Mitel actually manufactures their own for MyVoice Business. It's MyVoice Border Gateway. And Microsoft is working mainly with audio codes, and they've started supporting a smaller company called ThinkTel, and then Oracle has decided to get into the session border controller business as well, with mainly with doing virtual session border controllers. But never sit there and let a carrier tell you that you don't need a session border controller. That's just a myth. It's something you don't want to go down that path, because long term, the flexibility and the granularity you gain by using that, it's worth the investment. I'm going to kind of step a little bit away from where we've been talking about slides and doing things. Just talk about some real world things that you have to consider when you're looking at moving to SIP. One of the things that what IPC finds when we're doing these projects, probably the biggest time consumer of the whole thing, is getting the porting arranged and approved and scheduled with the carriers. If you're going from carrier A, and I'll just use AT&T, Windstream, or somebody like that, and you're converting over to Intellipeer, Windstream, SIP, whoever, but you're converting from PRI to SIP, and you're going from one carrier to the other. A lot of times the losing carrier is not real crazy about that, and they tend to cause headache when you're trying to put port requests in. Be aware that there is a federal regulatory group that supervises over porting requests. And if they have to step in and they will say, all right, you need to play nice, they will. Most of the carriers have gotten to the point where they recognize that, you win some, you lose some. But occasionally you'll have delays just being caused by porting requests being rejected. So if you're planning to make a move, you generally want to leave at least 45 days. If you're talking about porting over 200 DID numbers across your organization to SIP, try to at least provide 45 days to 60 days for doing the porting request and getting it approved. Because, case in point, we had one guy that was doing that, and we found out that he had 3 different carriers that he was using. Only one was connected into the phone system we provided and supported, but the other 2, they were doing remote call forwarding on DID numbers, and we had to go find all those DID numbers that were on the other 2 carriers. All of those numbers had to be ported, but it took us a while. It took us about 30 days to get all of the DID number information from all the carriers that we were dealing with. So I just wanted to make sure, we're talking about all the pieces and parts of things, but in the real world, probably your biggest headache will be getting the porting request to go through. As far as doing the deployment and setting up the equipment, we do this all the time. It's nothing difficult. It's just a matter of how do you want to build the system. That being said, what I've done is I provided some basic configurations for how you can set up SIP. And I'm going to take you from the basic configuration here to where the security and the IT people at one of our customers went off the deep end. And I'm just going to kind of show you different configurations and how you can do things. And these are not all the different ways. This is just some of the ways that we see on a day-to-day basis. In this particular design, you have your internet service provider and you have your traditional internet connectivity. And what has happened, they have enough bandwidth available. So what we do is we work with a certified SIP provider. We come in, we overlay the SIP on top of the existing internet, hits the corporate firewall. The session border controller allows the firewall transversal, goes through the DMZ, and then that in turn does the translation and hands it off to your traditional PBX system, whoever, the My Voice Connect, My Voice Business, Cisco IP telephony, whoever. It hands it off to whatever device is doing the SIP translation at this point for the PBX system. This has already done all the work. This is just taking that signal and saying, okay, here, I'm handing this off to you now for dial tone. That's just a basic, everyday configuration. We see and do this all the time. Where we usually have to do a little bit of work is we have to coordinate with the internet service provider to get some of the public IP addresses that we have to put in on the session border controller. And then we have to do a little bit of working with the IT department to open the ports and the necessary functionality between the firewall and the session border controller. But this design is standard to do this all day long. Occasionally you come into accounts where you get the information, somebody's popping 70, 80% on their internet circuit. At that point, we say, probably need to think about putting in a dedicated circuit. And they agree, and they say, okay, let's do that. So, again, we can have an internet circuit. It can be provided by a lot of the SIP providers will put in their own circuits if you ask them to. Or you can get it from somebody. You put a second circuit in, just put, again, certified SIP provider, puts the SIP trunking on top of it. It goes to the router. Router comes up, hits the firewall, does the handoff. So you have the blue, which is your traditional data, and then you have the red, which is your SIP trunking. And again, that's pretty straightforward. I mean, there's nothing bizarre about this. I mean, just you're eliminating an issue where you have a circuit that's too full. All right. So we've built a basic. We've done it with a dedicated. Then the guy says, well, I want to have some redundancy. So basically what we wind up doing here is we'll bring in this connection into the session border controller. We'll bring in the red into the session border controller, which is your traditional SIP trunking that we're using. And the session border controller and the SIP provider are monitoring the IP address ports. If it sees that it's unable to ping or connect here, it will fail over and use the public IP address port over here. When this comes back up, it will automatically fail back over to the primary source for internet pipe that you're wanting to use for SIP trunking. And again, if you remember earlier what we talked about, this particular design did not have enough bandwidth here, so this is just a short-term solution to provide connectivity and failover. So that's kind of the idea for giving a basic failover design. What we're seeing a lot of nowadays is where people are going to certified SIP providers and they're going into a colo or one main hardened data room that they have that has a generator, has VMware or Hyper-V, so they can do failover imaging, things of that nature. They bring all of their SIP trunking to this location, and then they just hand off dial tone to the different sites within the organization. We see this a lot nowadays. They like, carriers, some of the carriers up here are getting to the point where they're providing additional carriers into one. So there are a couple of companies where they'll bring in 4 or 5 different carriers. It comes into here as one IP address, but above here they have multiple carriers that they're bonding together to make it look like one IP address. So if any one goes down, they continue to function and run. But again, this is a very standard. It saves money in the long term because you have centralized SIP providing dial tone to all of your locations. The question becomes, okay, well, what happens if this has an issue? Redundant sites. We have it right here. This can be either in a colo data center, or this can be on your site. And if you have a hardened room or data room on your location in one of your buildings, you can put it there. And then people are putting a failover site or redundant site up in a colo or data center. Same situation. It's sitting here monitoring and watching this. This goes down, all the dial tone just redirects and goes through here, continues to function as normal. This is a very, very standard design, very popular design that we see all the time nowadays. A lot of times depending on how busy and how big the company is, sometimes they want to do active between the 2 locations. Other times they like to do active and passive. Active on the primary, passive over on the redundant side, but it can do either one. It can do active or active passive in this design. And so that's really where you get into the hardcore, centralized, reduced cost by having centralized SIP, and we want to have redundancy to protect it so there's no single point of failure. Right here, this is a matter of whether you want to put 2 different pipes or not in for your corporate WAN. That's your decision. You can put 2 different internet pipes, and then you really have more redundancy. We took this presentation, showed it to one of our customers, and they liked it so much. We had SIP failure run amok. So we had a primary site A, and it had subordinate sites where it was doing centralized SIP, and we had this particular site had its primary here, and then site G was backing up A. Then we had over here, we had site B with site A backup. You had site C with site B's backup. And you kind of get the gist of it. I had to have some long conversations with their security and IT people, needless to say, about can you do it? Yes. Do you want to do it and try to maintain and control all of this? Not really. I had two different SIP providers that said, yes, we can do that. Why would you want to do that? So eventually they kind of backed away from it a little bit and decided that this was not going to be the path of choice to go down. But this design, even though it looks busy and strange, this design provides a lot of redundancy and would work. So just be aware, you can do a lot of things. And what I've just shown you with these slides are not all the different methods that are available. Eric, I was going to hand this back to you at this point. If there are any questions that people would like to discuss or address.
Yeah, we do have a couple questions that have come in. One question is, how reliable is a SIP handoff versus PRI? Are there any statistics you could share? Let me take that first, and then you can add to it, Jonathan. So, SIP is a protocol. The point where SIP breaks down is not in the communications protocol; it's the road it's running on, right? The reliability of the circuit that is being provided by your carrier, either your internet circuit provider if you choose to run SIP over your internet connection, or if you have a dedicated circuit from a carrier for a dedicated SIP connection. The reliability is really based on the reliability of that circuit. So the answer is you're going to find the reliability to be dependent upon each unique situation and scenario. So it's SIP is the car and the network is the road. You could have a Ferrari driving down a 10-lane highway, or you could have a Ferrari driving down a dirt road. And the reliability of your experience is more reliant on the road than the car. And so, my initial gut response to that question, how reliable is SIP versus PRI? The SIP is reliable. What is the piece where you're going to want to be careful is the road it's running on. What circuit is delivering the SIP communications protocol? Jonathan, did you want to add anything to that response or that question?
The biggest thing I can tell you on that is the majority of the PRIs that are in place, particularly in city area, metropolis areas, most of the PRIs that are in place right now are running on SIP. They're coming in on SIP and they're just being handed off to an IAD, which says, here, I'm going to hand it to you as a PRI. But almost all, I would say easily 60 to 70% are SIP-based right now, SIP-based PRIs.
Right. So you're already using it. You may not even know it. They're just taking that device and converting that signal because your PBX has a T1 card in it or a PRI card in it, and that's the signal. That's the interpretation it needs to receive. So it's coming into a SIP into your building, and then they're converting it to primary rate interface because that's what your PBX can speak at the moment. And so that's that's sort of another way to explain what Jonathan was referring to. Couple of notes here. So we do have a carrier team here at IPC, and there's just some notes here that have been added. When you do look at SIP, you will need static IP addresses to make the connection over the ISP. You don't want them. You're going to need to provide. The SIP carrier will need to provide static IP addresses, and you'll need to have static on your side to make that connection. You want it static, not dynamic. One of the other points that our teammate made on the questions here is that because SIP actually provides more options for redundancy as compared to a PRI, right? A PRI is a circuit-based technology. It's point-to-point. Because SIP is a packet-based, it's session-based, not circuit-based. The ability to deliver multiple paths and multiple routes and redundancy is enhanced when you migrate to SIP versus a PRI infrastructure. So good points and good questions. We have another question here. How much bandwidth does SIP take up, and what would be a good internet speed to have for SIP? So let me start with that one real quick. I kind of want to answer the second question. It's a little bit related to the first question about the reliability of the road that you're running on. So bandwidth is one quality of a circuit. The other things you will want to concern yourself with are things like jitter and latency and packet loss. We have seen very heavy bandwidth rich environments with QoS delivered on them show bad call quality because of dropped packets inside a carrier's router. So we have some advanced tools at IPC that allow us to shoot and sequence. We have a network sequencer application that we use in order to prove out what is really happening over the wire. Because your carrier could say, yes, we have QoS and those types of things. But if you've got a router in the cloud that's dropping packets, you're going to have a bad experience, even if QoS is running. So there are, QoS is prioritization, but packet loss is packet loss. And so it's more than just the bandwidth answer. It's bandwidth, it's latency, it's jitter, as well as packet loss associated with it. That's been my experience. Jonathan, what would you add to that? So first of all, how much does a call? I guess it depends on the codec you're using. What's the range of bandwidth you would want to have per call?
Yeah, generally, you between G711, G729, you generally on a call you're looking at about between 80 and 100K. So I use, that's usually what you're looking, depending on who you're dealing with. But realistically, if you use a range, if you use 90K, that's a pretty good rule of thumb. So if you have 10 calls, you're talking 900K. So that's inbound, outbound. With internally, it doesn't take that much. Internally, it's just running strictly on the data network. But inbound, outbound on SIP trunks, you have 10 calls going on, you can kind of figure 90K. But figure 90K per call, so that's 900K. So if you're talking about somebody's got 100 megabit bandwidth, I mean, you're talking less than 1% on that. So it's a minor amount. And we usually separate that traffic. It doesn't become an issue.
Yep. Okay.
Any other questions?
Let's see here. There was another question about what on the Mitel system. So Mitel, we have customers that are both or all three, I guess. We have MyVoice Connect customers, which is the majority of you on the call. We have MyVoice Business customers. We have MyVoice Office customers. And so where do I find, the question is, what SBCs or session border controllers are certified with the Mitel system? And another question is, do you have recommended SIP providers associated with it certified? When I saw that question, I did a quick search. If you go to mitel.com and then in the upper right-hand corner, click on the search icon and search for the words SIP COE, SIP space COE, which is the Center of Excellence. You will, the first link that shows up in that search will give you an interoperability link that takes you to the Mitel Solutions Alliance page, where you'll find the latest version. Just downloaded the latest version as of October of 2019, and it shows all the carriers that have passed certification tests with the various platforms that Mitel services. So again, go to mitel.com, click on the search, type SIP space COE for Center of Excellence, and you'll find a document there that'll show you who's been certified. Now, I did look at the document, and there was a lot of them in there that are yellow. And if you look at the legend, what yellow means that it was certified, but it just hasn't been renewed. The certification, it hasn't passed through a recertification in the past 12 months, I think it said. Maybe it was 12 or 18 months. So if you see something that shows yellow, it doesn't mean no. It just means that based on Mitel's testing through the Solutions Alliance, they have not recertified that SIP carrier on the platform that you're considering within the last 18 months. So at one point it did work, and it's likely that it still does, but that will give you that information to answer the questions on session border controllers as well as SIP providers. My personal experience with SIP providers is that all of them are good and all of them are bad. I think what you want to do is partner with carriers that you have tight relationships with. At IPC, we have found a lot of success and have built a lot of great relationships with our IntelliPeer partnership. And so what that means is that we have a good support infrastructure in place to address concerns and problems when stuff goes bump in the night. And so make sure that when you do select your SIP carrier, that the relationship is paramount to that. At IPC, I would say our tightest relationship with a SIP carrier would be with IntelliPeer. It's the one that we recommend because we know it works on the product. We know how it works. It's easy to deploy, easy to configure. It's priced effectively, priced right. It's not the only one out there, and we understand that there are carrier relationships abounding, and sometimes you may have MPLS that they're going to bundle some SIP with, so we understand there's a lot of different options. And so that SIP COE document should be able to help you narrow those down, and obviously we can help you as well based on our experience. Jonathan, any other thoughts on session border controllers and SIP providers?
You hit that pretty well on the head. That I mean, if you've got a diversified group of PBXs like that, just from a managerial standpoint, I would think you'd want to try to get to a single platform. You know, you might have independent offices where you might want to put like a small business edition, but I would think you would want to try to get it to eventually where you'd be on the same platform, so you have the same equipment, so you're able. So from a support standpoint, to make your life a lot easier. That's just
right.
An observation.
Yeah, I mean, I've seen, you know, the session border controllers. So if you're a MyVoice Connect customer, the session border controller that is sort of the OEM version that is provided by Mitel is actually an in-gate separator, and that's the one that we have a lot of experience with. If you're a MyVoice business customer, the session border controller is a product called Mitel Border Gateway, which acts as the SBC. I do know that Mitel has plans to consolidate the multiple SBCs from a Mitel perspective, like what will they OEM and sell as going forward. And I do know that out of those two, the direction that we are receiving from Mitel is they're going to go towards the Mitel Border Gateway for future. They will still fully support the in-gate product. There's no sunset on support. There's no discontinue on that, but the direction that I'm hearing from the product management team at Mitel is that it looks like what they're going to do is make it so that the Mitel Border Gateway product will work across all platforms as a certified SBC solution. So that, and I do know that we've interoperated with other products before. Just need to be careful that it's been certified on the COE. I did see another question there about what SIP carriers are certified. So hopefully the answer, right? Remember, go to mitel.com, click on the search, type SIP space COE, and you'll be directed to a document that you can download that lists all of those as of October of this year. Okay, it is 11:59, so we are right on time with our timing. I wanted to thank everyone for their time. This will be recorded. We can send out a link later, or you can find it later this week on the IPC Tech YouTube channel. And we appreciate everyone's partnership and hope that these customer training webinars you find them to be helpful. If you have a request of a topic that you would like us to address, please send it in. You can send an email in to your account representative or anyone on the IPC team, even through our CSC, our Customer Success Center, if you'd like to see a certain topic that we don't have loaded up. I do want to say, let's see here, Jonathan, if you're still sharing the last slide there, it does show, if you can hit next one more time, it does show the next two sessions we have. We're going to talk about, there you go. So next session in December will be building a better work from home communication strategy. So if you're growing your teleworker business or your teleworker services for your internal customers, we've got some neat solutions for that. And then I think we didn't really schedule the best path to the cloud correctly. It's on Christmas Eve, but if you guys want to attend on Christmas Eve, we can do that. If not, we'll probably push that one into January for just talking about how do I consider the cloud? What is the cloud when it refers to unified communications, and what are some of the things I want to consider if I'm evaluating options around there. So those are some customer training webinars that are coming up. Thanks everybody for their time, and have a good rest of your Tuesday.